right. Good afternoon, everyone. Hey, how's it going? Hope you've enjoyed a nice, refreshing lunch and avoided the outside, because it seems to have become opposite day in terms of weather. I don't know if it's raining, it's crazy it's out there. Anyway, thank you for coming along to my talk this afternoon. Let me just start by introducing myself. My name's Phil Nash. I'm a developer evangelist for a company called Tulio. Can I ask just quickly, has anybody here heard of Tulio at all before? Yeah, a few. All right. Anybody who was in the previous talk, I might have mentioned it. Thank you. For anybody that wasn't there, doesn't know about Tulio, we are a communications platform for your applications to connect or communicate with your users via voice, video, or messaging using the tools, languages, or frameworks that you already know. I'm not obviously here to talk about Tulio, but if you do have any questions, if you are interested at all in that, then do please come and find me. I'll be around in this bright red t-shirt for the rest of the day, so come and find me, ask me anything. If you are interested in following me at all online anywhere else after this talk, then those are my details up there, Twitter. Feel free to email me at Tulio as well. Cool. So, an empty database in every pocket. Thank you for coming along to this potentially cryptically named talk. What I want to start with is by saying that I think there are a few problems that we have to deal with when building web applications these days. We are obviously writing code and building an application that works is the first one, but building something that works well it becomes the problem after that. And so we are, on the web at least, we have to deal with things like performance. Building an application that loads quickly and then works well once it has loaded is one of our biggest problems. And secondly, dealing with offline. I mean, I guess offline is not really our problem. Like, you can't deal with, if a user is just not on the internet, then it's kind of their problem. So maybe poor connectivity is an issue for us. But again, this is something that we can't really control. So you can't fix poor connectivity as a developer with an application. So what I really think is important when we're building these apps is resiliency. Building an application that it doesn't matter if you're offline, it doesn't matter if there's poor connection. Building an application that is resilient in the face of failures that you cannot control. And these I think, are our problems. And ultimately, it boils down to building a good user experience. I didn't have a picture to describe user experience, aside from this one of my dog, who I think looks so happy after she was tucked into bed. This, I think, is the experience we want to give our users, the experience of a happy dachshund that's been tucked up, ready to sleep. Or maybe I just wanted to put it in because it's a really big screen and a cute picture of my dog. I don't know. But what we're trying to do as developers in general is build an app that works and works well, gives our users a good experience. So, you've probably heard this term. Again, you'd have heard it if you were in my previous talk. But we are building, for the web these days, progressive web apps seem to be the way that we can control and make this experience better. With the power of the service worker, we can cache files to work offline so that in areas of no or poor connectivity, a user can still load a website and see the HTML that we have there. But what I think we're missing out on a lot when we talk about progressive web apps, because there's a lot of excitement about the service worker and caching files, what I think we're missing out on is about the data within those applications. It's not enough to just save a bunch of HTML, JavaScript, and CSS so that users can see a site. Our sites are dynamic. Our applications have a lot of data that they use and supply to users, and that's not page-based. It's not page-based data at all. And this is why I'm here to talk about what I think are these empty databases. When I say in our pocket, I really mean on our devices, although this does, of course, mean laptops as well. And I want to talk about how we can store, save, and use data in the front end for our applications. So we have some options for storing data in the front end. Some of them have been around for an awfully long time. Cookies, for example. Now, they're not the best way of storing data, we know this. You have a limit of about 4K. They get sent as a header with every single request that a page makes. They're very good for saving little bits of data, session identifiers, for example, or JSON web tokens, that kind of thing. But they are not great for saving our application data. Useful as an absolute last resort fallback, though. Local storage. Who here has used the local storage API? Right, quite a few people. Quite a nice API, right? It's easy. We just set an item, and then later we go and get the item, and it's done, right? This is a great way of saving data, except it's not. Because local storage has a number of problems to it. I'm not saying you should never use it. It's useful in certain situations. However, in this world of progressive web apps where we have a service worker and things like that, local storage exists as a synchronous data store, which is not acceptable in the eyes of a worker, service worker, or even web workers. It also, because of this synchronicity, can cause other performance issues within an application. When it is saving data, and if you're saving a lot of data, then local storage, because it blocks on the main thread, can cause jank or other performance issues in the rest of the application. So it's not the best API to use for this. It is nice and easy, and that's definitely a positive for it, but it has other issues. Web SQL? Has anybody tried using Web SQL before? I've actually not myself, so yeah, one there. Web SQL is a nice idea, right? A relational database in the browser that we can use to store and replicate kind of part of our application. Lovely idea. The browser vendors thought it was a lovely idea too, because they all implemented it. Their only problem was they all implemented it using SQLite as the backend. That is a stable and decent database. However, the rules of the W3C and standards are such that in order to become a standard, a feature has to have two separate implementations by browsers. Because the browsers all implemented it using SQLite, that was only one implementation. And so the W3C deprecated the Web SQL proposal, and we are not having it anymore. It's going away. Some browsers have published their intent to remove completely the Web SQL from their platforms. So it's gone. So that leaves us with IndexedDB. Anybody else feeling joyful about that? Yeah, well, right, thank you. Has anybody else used IndexedDB at all before? No. Okay, cool. All right, cool. And why is that? I think possibly because IndexedDB has a bit of a bad reputation. People know it as an API that's awkward to use. It's certainly not as easy as local storage. And I want to change that perception, I think, for now. That's my aim here, is to give us the ideas and the opportunity to go away and choose to use IndexedDB, because it is a quality database that we can make our applications better with. So, what is IndexedDB? This is just a little bit of a rundown of what you can expect from the database. So first up, it's an object store. A local storage, as we saw, is a key value store, which basically has values of strings. This is great if all you want to do is save strings. However, if you want to save more complicated objects, then you have to stringify that, serialize that into something like JSON, which you serialize on the way in and parse on the way out, adding, of course, to that performance overhead from the synchronous API itself. IndexedDB is an object store. You can go and put objects into it. JavaScript objects, that is, of course. And they just work. You put them in, you bring them out, and they are reinflated for you as real JavaScript objects. So no messing around with parsing it. IndexedDB is a transactional database. This is useful on a number of reasons. Of course, having a transactional database means that we can tell whether the transaction did in fact work and go through. But it also means this leads on to how IndexedDB works, which is you kind of build up your transaction, you build up the data you want to put into it or get out of it, and then you give that transaction to the database, at which point you kind of wait until that's been dealt with, and then you get that callback for it. So it makes it an asynchronous API. We just let the browser deal with making the writes and reads to the database. We just make a request to do this. This asynchronicity, of course, means that we can use IndexedDB within a web worker or a service worker, and so is why I think it is the database for the progressive web app future that we're trying to build. It has the same origin policy. This is just the security note. Like, you can only read an IndexedDB, read information that you put into IndexedDB from the same host, port, protocol. It's much the same as any other JavaScript. You might be wondering about support for IndexedDB. Maybe nobody's using it because you don't think anyone's implemented it. But no, it's actually supported pretty much across the board. Opera Mini, of course, supports nothing. So, yes, we have greens on all the other browsers. We have an oddly colored green for Internet Explorer and Edge, which in this particular case means a partial implementation. I've looked into the details of this, and it seems that pretty much the only thing that Internet Explorer and Edge did not implement was the length property on a number of objects within IndexedDB. So it's not the most disastrous partial implementation. You can go and use IndexedDB in all of these browsers, and that's cool. So instead of just talking about IndexedDB and kind of waving around the idea that maybe it's not got the best of APIs and things like that, I want to show you how it all works. And so for that, I have a bit of a demo. And let's just make sure it's all running. Yep, cool. So this is my demo. It's a chat application that I've built on top of the Twilio chat API. And it only takes emojis. That's a tiny little thing there, isn't it? Here's my favorite emoji, because why have one beer when you can have two? You can actually join in this chat, because it's very boring if it's just me, by going to that URL, philnash.ngrok.io, and you'll be able to join in the chat. But what I'm going to do with this chat is make it work quicker. So what happens when you load this page is that, of course, we load all the HTML, we then load the JavaScript, and then in order to connect to the Twilio chat SDK, I then have to load an access token for the SDK, which comes from the server. Once I've done that, I then have to initialize the SDK and make the connection to the Twilio SDK. So some of this can take a little bit of time. I'm going to go ahead and refresh the page here, but if you're still typing that, it's philnash.ngrok.io. And so what you can see is when you refresh the page, if you look right at the bottom, we have this green send button. All right, we have some people, cool. The green send button starts off disabled, it starts off gray, and will only become green once the whole thing is loaded and we're connected. And so if I refresh that, you can see it's gray, and we're connecting, and we're doing the connection, then we get there. And then we load the messages, and then they arrive. So this is not the best of experiences necessarily. The way I've built this right now is not the best of experiences, because you want to see the chat messages when you load this up, and all you're seeing is kind of this blank white screen waiting for stuff to happen. So let's fix that. Let's make that better. This is the application. Hopefully you can read that. That's nice and big. What we're going to do is I'm going to use IndexedDB to save the messages that we've seen on the page and then load them instantly as the page arrives. That way, we get a good experience of seeing the page and the messages load snappily whilst we're still doing the connection in the back end. So let's start by initializing our database. I'm just going to start by creating a variable db, which I'm going to use for the database later on. And what we're going to do is make a request. This is our request to the database. And this is to index open. And we're going to open a message store. And we're going to open it at version 1. That will become important later. So when we open the database, we have to tell it what object stores we want to have in there. So this request has, well, let's start just in case things go wrong, we might get an error. So we have a callback for that, and if something does go wrong, we'll just log it, and hopefully it won't happen. There we go, cool. So now we need to know whether we need to upgrade this database. We need to add in our object stores. So this has the fancy name of onUpgradeNeeded. Really weird event name. And that fires as an event. We're going to start to see quite a bit of these events as part of IndexedDB. One of the first parts of that is that the event always stores the subject of the thing you're trying to do. That will become more clear later as we see more of them, but in this case, we have event.target.result. This is always pretty much an item in the events in IndexedDB. And in this case, the result of the event is a database that is waiting to get upgraded. We can then use that database, and we're going to create ourselves an object store. This is, so we have a database. This is like having a table within that database. It's not a table, it's an object store, but that's what we have. We're going to call that messages, and we're going to give it some options. The first one is key path, which is SID. So the key path here is the key for the object in the store. Messages from the Tulio chat API in this particular case come with their own ID, so we can use that ID inside the database as well. That ID is called SID. I'm not quite sure why. You can, if you were to name this something else, then you can also set auto increment to true, and that will just auto increment IDs for you on the store and make them up yourself. Quite useful. But we have an ID, so in this case, I'm not going to do that. Cool. That's all I need to do in terms of upgrading that database. So then, if that all works successfully, then the onSuccess event should fire, which is also get an event object. And in this case, I can now set db, which is that variable I put on line 14 right at the top there, to, in this case, event.target.result. So this is now the upgraded database that is ready to receive objects into the store. Cool, so that's starting our database. Nice. Now we need to put messages into the database. So in the chat, in this case, I have a chat object, and that receives events when a message arrives. And so when that happens, we both add it to the page, and now I'm going to add it to the database as well. So, as I said, with IndexedDB, everything's a transaction. So we take the database, and we open a transaction, and we have to tell it at this point what stores we want to use from the database. So we can pass an array to this, and I'm going to say I want to use messages, and I want it in read-write mode, because I'm going to add things into the database, so I need it in read-write mode. I can actually just use a string here. If I had more than one object store that I wanted to use, then an array is what you'd need. With that transaction, we then get the object store itself from the transaction, which is the messages store. And then we can make our request to the database to the object store of the transaction. So request is equal to. And we're going to use put. So there's two ways of adding something to the database. You can use the add method, which will append it to the database, or the put method, which will, if it matches the ID, just update the message in the database. If the ID is not found, it will just add it. So in the case of in our application, we have these messages coming in with IDs, so we won't overwrite the messages or add duplicate messages if we use put. I'm just going to put the message in there. Like I said, it just takes JavaScript objects. So we just put it in there. And that's it. So we can use the request to then listen for success and error events. In this case, we can just be like, yeah, it worked. And if it doesn't work, nope, that's not what I meant. If it doesn't work, we can just log that as well, just to make sure. Cool. So that is adding things into the database. We get a transaction from the database. we get the object store for the transaction that we want to use, and then we put the message inside into the transaction. If I refresh this page right now, wow, love hearts, that's cool. It still takes a while to run. That's good to see. There's some errors, which is also terrifying to see. IndexedDB is not defined because it's got capital B. Of course it does. That's good. All right, errors have gone away. It's good to see. And so those messages are all loaded in, and so we should actually be able to go to the IndexedDB section of the of DevTools and refresh that. And now we see we have, let's make that a bit bigger. We have a message store created, which is cool. And inside the message store, we have the messages object store. And these are all our messages that we've put into the database. As you can see, we'll check the last one, which should be somebody with a hand up. There we go. So right down the bottom there, if you can see, we have our objects in the store. Cool. This doesn't help our loading of the page yet because we are only putting messages in. We're not taking them out. So let's go and do that as well. Some good emoji game there. You'd be surprised what people try and send to an emoji chat. Right, so now we're on load. We want to load those messages snappily out from the database onto the page. So this event here is probably the best place to do that. Once we have our database set up in the first place, then we can start using it. And this is kind of on page load. So what we're going to do is get a transaction. And this is where you kind of see that the IndexedDB API is actually quite repetitive. We do the same thing over and over again. We get a transaction from our message store. Nope, messages. In this case, in read-only mode, because we're only going to read things out of the database at this point. And then we get the object store from the transaction. The messages object store, and then we create a request. So you've seen this all before, right? And this, I think, is one of the reasons that it is an awkward API, because there's so much repetition. However, this is why we have libraries to make this work better for us, and we'll have a look at those in a bit. But we're going to use the object store, and in this case, we can't just load all the messages out. We actually have to open a cursor, which will iterate through the messages from our store. So I'm going to open the cursor, and then, as you might expect, the request gets a success callback, which has an event. And the target of that event, in this case, will be our cursor. The event target result, again. It's the same properties, it's a different object this time around. And so with the cursor, what happens is the cursor returns to this callback every time a new element is pulled, a new object is pulled out of the database. So in order to iterate through this, we need to do a couple of things. First up, we need to check if we actually have a cursor. If we don't, then we're done. If we do, we get our message list, and we add a message to it from the value of the cursor at this point. That's just the property. And then we just call cursor continue, which sends it off to get another object and return it to this callback again. If we don't have the cursor anymore, like I said, then we're done. We've retrieved all of the objects from the database. And so in this case, we take our message list and we call render messages, which is just a method from this application that I've written that renders them to the screen. We could render them one by one as we get them out of the database, but I've saved it to the end. And that's what we need to do there. So on the success event of our cursor, retrieving another message, we add it to a list, and then we render that list when we have got through all the messages. So this time around, if I reload the thing, we see that everything snaps in really quickly. We've just gone and got all those messages right there and then more ones can come. And so one more time, I just want to kind of look at the green button at the bottom, or see where it's gray right now, but the messages are there. And we're still doing the connection in the back end, and once we can start sending and receiving messages again. So this is kind of, with just a few lines and no libraries whatsoever, this is the power that IndexedDB can give to your applications in terms of adding performance and making things work better. I'll leave you with the emojis if you want to continue with that. But that was my demo. That's the application now working quicker because of IndexedDB. Of course, there's more. That's just a very simple example of how to get started with IndexedDB. And we don't use any kind of the advanced features. So to think about them, we have, first of all, indexes. It's called IndexedDB, so I suppose we should talk about the indexes. In this particular case, the kind of ordering of the messages is actually basically based on the ID, or non-determinative ordering. However, with an index, we can order our messages, and then when we get our cursor out, we can do it in the right order. When you create an index on IndexedDB, you just have to choose another of the properties that you expect to be on the object to use. So in this case, if we actually created our original database with an index called dateUpdated, which is another property that would come through as this message in my example, then we'd have an index based on the dateUpdated order. And then when we then go and get the messages from the store, we could do that using the index. And so instead of getting them straight from the object store itself, you can use the index to then open the cursor. Then there's upgrades. So we saw the onUpgradeNeeded event, which is an awkward event at best. But we opened our database in version 1. We saw that. And this is what it kind of looked like. However, as an application grows, you might find you want another index or another object store to save data in. And so we need to add these objects to the database, these stores to the database, or indexes to the database. And so if somebody's seen this, if a browser has seen this application before and has the database at version 1, then we need to be able to add things to kind of a new version. But we also need to support users that have never seen the database before. And so this is how that works. You start that, you open the IndexedDB, you use the new or latest version, and then we need to check within the upgrade event what version the browser currently knows about, and then add things to it. So this is a non-exclusive kind of set of ifs here, so that if this is the first time a browser has seen the database, then it's going to run through all of those conditionals. If it has seen it at version 1, then it's going to miss the first one, but it's going to get to the second one and load in a new object store for channels in this case. And that obviously can grow quite a bit. You might want to change to using a switch statement rather than a bunch of never-ending ifs. But this is all you kind of need to do in order to upgrade and use the database further down the line. It's probably a good idea when considering something like this to talk about the gigantic bugs that have made it awkward in the past. And that really comes down to Safari. I'm not calling Safari a bug, but it did cause some issues with IndexedDB in early implementations. So the problem with Safari and IndexedDB was that if you had two object stores, and they both have IDs, key paths, and you put an object into one store which had an ID, and then you put an object into the different store, the other store, and the ID matched the original one in the other store, then Safari would wipe out your original object. I know, terrible, right? It's just an awful, awful thing. This was evident in Safari 8. They got closer to fixing it in 9, but it is fixed since Safari 10. So IndexedDB is very usable in Safari now. You could get around it by kind of managing your keys with maybe a prefix on the object store such that you would never match IDs between object stores. However, that's a bit of an overhead that you don't want to have to do. So Safari was a nightmare. It's less so now. So I said that IndexedDB is quite a low-level API. In fact, I believe the API was in fact based on the XML HTTP request API with these kind of callbacks and event targets and things like that. Quite a weird thing to build a database based on, a database API based on the Ajax API, but that seems to be what they did. So if you are unimpressed by the amount of repetition with getting transactions, if you're unimpressed by some of the bugs and having to do workarounds, then we have libraries to deal with that, of course. IndexedDB really is quite a low-level API in in reality, so it's best to take an abstraction on this. These are a few that I've checked out and used on occasion, and I'm going to show a few bits of them in a minute. But just to let you know, IDB val and local forage both give you basically a key value store like local storage, but asynchronously. So this is quite a simple way of dealing with it. IDB val is quite amazing in that it is about a 500-byte library. It's the tiniest little wrapper around IndexedDB, but it gives you that key value store nice and easily, using promises in that particular case. Then we have IDB. Both IDB val and IDB are written by Jake Archibald. IDB is a thin wrapper around IndexedDB that removes the callback nature, the on error, on success, on upgrade needed, and replaces it with promises to make it nicer. And then we have DEXY, which is it's quite a nice abstraction on top of IndexedDB, and PouchDB, which is a implementation of CouchDB in the browser on top of IndexedDB, all the way up to including the sync protocol for CouchDB. So any browser using PouchDB basically becomes just a node within a distributed set of CouchDB instances. I think that's quite incredible for just a browser API. Well, let's have a look at a couple of these and how they work, rather than me just talking about them again. Like I said, IDB val is really quite nice. You just set and get values, and they come out via promises, which is nice. So that's just if you successfully set the key, it will return successfully, and otherwise won't. And that's all there is to it. Nice and easy. Local forage is very similar. Although you can actually use callbacks or promises in local forage. You have a choice there, which is nice. As I say, yeah, callbacks. It actually looks exactly the same as IDB val, which is cool. Local forage itself is a much bigger library than IDB val because it actually does deal with workarounds for bugs and other browser inconsistencies. So if you want to quite seriously use IndexedDB via a key value store like this, local forage is probably the best for your browser support. If you're on bleeding edge browsers and you don't really mind and you have a promise implementation, then IDB val is this brilliant tiny wrapper. IDB itself just makes the whole thing look a lot nicer. You still have to do transactions and you still have to do that kind of repetitive stuff. However, when you, for example, open the database, you just, rather than using the onUpgradeNeeded event, you just pass a callback. And then the rest of it works via promises. So, and this does the whole kind of transaction there. DEXY, as I said, is a bit more of a fully featured wrapper to this. So it has quite nice versioning, as you can see, for databases. If you wanted to make version 2, you just call dexy.version2 and add stores to that. It saves you having to build up your giant if statement or switch statement in order to properly upgrade databases. And then once you have that database and it's open, DEXY actually comes with quite a nice little querying interface as well. So in this case, this is just getting a single ID, single message out of the database. But it just kind of shows the power that you will then have using something like DEXY. And PouchDB, like I said, is quite something. This very much, it's promise-based, but is the implementation of CouchDB. So when we are putting something to the database there, that is kind of matching the HTTP equivalent of the CouchDB API. And allows you to deal with, as I said, the syncing, and it will bring you back sync errors, and everything is kind of handled quite amazingly. So highly recommend checking this one out. PouchDB actually has, I think, an interactive builder. So if you don't intend to use the sync stuff, but you still like the API for it, you can build a smaller version of PouchDB to use on your site. Just to cover on the workarounds and things that things like the Safari bug, I think both DEXY and PouchDB in Safari 8 and 9 will actually use WebSQL as the underpinning database because it's available there. However, now that Safari 10 has got it fixed, I believe they now use that when you're in Safari 10. So it does do the workarounds for you, in this particular case, by using an entirely different database. But as I said, IndexedDB right now is happy and should be used. So that is what I wanted to talk about with our databases. IndexedDB is a feature that is available in pretty much all of our browsers right now and today. You can go home and use it tomorrow. And you can use it like, I wanted to share that little example of a chat which now loads much faster, just because I think we can enhance the user experience by storing data offline and making things work like resiliently. It's a perfect accompaniment to progressive web apps if you're building that kind of thing. IndexedDB can help you enhance the experience. It can improve performance of websites, and coupled with a service worker, can improve the resiliency of your websites as well, as the data can be stored at the edge with the user, not over a network connection. So let's go out there and fill those databases. Thank you very much for joining me this afternoon. That is an empty database in every pocket. Thank you. I've got one little request before we maybe go to questions, and that is that if you do like Tulio, if you know Tulio at all, we are looking for people to write on our blog, and this is obviously a great community full of very intelligent and attractive people. And I don't know where I'm going with that. If you are interested at all in writing for the Tulio blog and getting paid for it, because we pay our authors, then please head to tuliovoices.com and sign up there, and somebody will get in touch with you. We'd really like to get more community voices onto the blog, so please go and do that. And then we have a few minutes left, so does anybody have any questions at all about IndexedDB, or basically anything? We have a question at the back. Yeah, go for it. The main difference, apart from being synchronous or asynchronous, so local storage is a very simple store that can only store strings as part of the keys, as the values, whereas IndexedDB can store entire objects. So that means, so you have to serialize your objects into local storage if that's what you want to do, whereas IndexedDB will take the entire object and give it back to you as you gave it to it. That's one of them. And then you have things like the indexes and things. So if you have a list of stuff in local storage under one key, then you have to load it all out, parse it, and then look through the list. Whereas in IndexedDB, you can query, you can run a cursor over the thing, query the things as they are ejected from the database. And so those are kind of the differences there. It's certainly a more complicated database. Local storage is great for being simple, but if you are intending, the main killer for me, I think, with local storage is if you are intending to use it at all with a service worker, then you just cannot use local storage because of its synchronous nature. But IndexedDB is just more fully featured and saves you time and effort in terms of putting objects in the store. Cool. Any other questions at all? Sorry, go for it. Oh, so yes. Are you kind of talking about like how much data you can have and things like that, or? No, go on. What were you asking? I don't want to answer my own question. Is there rules about the eviction of data in the database? No, you are in control of your own data. Oh, I see. I mean, I don't think, if we go back to the application over here, and inside DevTools we look at clear storage, the storages are definitely kept separately, no, I don't think they're cleared when you clear the cache. They are cleared if somebody chooses to remove the data from a website. I think that's the same for local storage anyway. Not session storage, of course. That one is gone at the end of a session. But no, you're in control of the data. There is, I think, like data doesn't get saved in cases where you are in a private mode in Safari or in Chrome. Certainly Safari, that one makes that one difficult. But that's private mode, so you don't expect to save stuff. You know, cookies are going to get wiped out at the end of that, and things like that. Everything gets wiped out of private mode. But no, in normal modes, it's not ejected just for clearing the cache. But it did, sorry, you also kind of reminded me there of, and I want to answer my own question as well, which is about the size of storage. So another difference with local storage is that once, you can't get more than, I think it's 5 or 10 megabytes into local storage without the browser really having a complaint about that. Whereas IndexedDB is kind of open, I think, to, I think in Chrome it's 20% of the available storage that Chrome has available to it. So technically 5 websites could fill all of Chrome's storage, but then it would start to complain about things. But yeah, so you have basically a lot more space for storage in IndexedDB than you do in local storage. You had a question? Oh, okay, cool. Got there. Yeah, go for it. Yes. Well, that's what I mean. You can put large amounts of data in IndexedDB, and it's going to be fine. Sorry? It's not, well, I mean, you're limited by the space available on the machine, on the device, and the space that the operating system allows the browser to have. But, like I said, I think in Chrome you get 20% of that space. So it's quite a lot when it comes down to it. Oh, anybody? When you do what, sorry? Oh, when you exceed the space. Yeah, that's a good question. I've not managed to exceed the space before, so I should try that. Let's write an infinite loop that keeps putting stuff into IndexedDB. I believe if you exceed the space, then I'm not going to answer that because I don't really know right now. I will go look at that up afterwards, but I couldn't tell you right now, and I don't want to make up an answer. So yeah, I will go and check on that. Thank you. Anybody else at all? Oh, yes. So yeah, if you're trying to, if you're handling different users on the same, sorry, I should repeat the question so everybody can hear. The question is about how do you tailor handling data for different users on the same machine or the same browser, and that is up to you. I think basically, if you have a user log out, then it's kind of up to you to clear the database, lose all the extra data. If that's important or sensitive, well, you shouldn't really store sensitive information probably in the front end. But if it's important data, then for the user to use the application, then that should be cleared once they're logged out. That's very much a manual process right now. However, there is a spec that is being worked upon, which would make it possible such that when you do a logout or a timeout for a user, you could set a particular header on a request on the response to the logout, which would then tell the browser just to clear all data for a user. I think it's a really good spec for this kind of thing, and it would work with the service worker caches, IndexedDB, all these kind of things. That header would simply just clear it all. It's being worked on and experimented on, so it's not available yet, but that will make this kind of thing a lot easier to trigger on that logout. So keep an eye on that. I can't remember what it's called, but keep an eye on that. Anybody else at all? The data stored as plain text? I haven't looked into how it's actually stored in the back, but right, yeah. So it's not stored within like a what's it called on iOS? Sorry, operating. I don't think it's stored within like a secure data store. It is somewhere in the depths of a browser. But it probably is, I guess, plain text. Yeah. I don't think I would store sensitive information in it at all, no. I mean, that would make it subject to a cross-site scripting attack, for example, could empty a user's database of the data. So I don't recommend storing things like that, unless you're somehow encrypting it as well. But That's just asking for even more trouble. Cool. One last question at all, or? I think we're done. Well, thank you so much again. My name's Phil Nash. I work for Tulio. If you have any questions about that, come find me later. And enjoy the last couple of talks of the conference. Thank you so much.